Today we'll be discussing angles of elevation and angles of depression. So grab a pen or a pencil and get ready to take your notes. First, let's take a look at the angle of elevation. The angle of elevation is the angle between the horizontal line and the line of sight to an object when you're looking up. If you look at the picture to the left here, your horizontal line is what you're looking at if you're looking straight across. Your line of sight is where you're looking to if you're looking up at an object or down at an object. So from your eyes to the object. This is the line of sight. This guy's line of sight goes from him all the way up to this hot air balloon that's in the sky. The angle of elevation is that angle between the horizontal line, so if he was looking straight across, and the line of sight from when he's looking up. Now, an angle of depression is a little bit different. The angle of depression is the angle between the horizontal line and the line of sight to an object when looking down. Go ahead and add that word in. It's when you're looking down. So if we're in the hot air balloon and we have a horizontal line, which is this, we're looking straight across, and then we're looking down to a person that's on the ground, the angle of depression is between that horizontal line and the line of sight. Now, steps to solving problems with angles with elevation and depression is just like what we've been doing with our right triangle trig. But let's look at the few steps that we need to do. First, we need to draw a picture. A lot of times when you get one of these problems, you're not going to have a picture, so you need to draw that. Then you need to label the information that has been given to you. Next, you need to determine the trig ratio you need to use. Are you going to use sine, cosine, or tangent? And lastly, we're going to set up and solve your trig ratio. So let's get started on a couple of those examples. Our first example says, a hiker is standing 220 feet from the base of a hill. The angle of elevation from where he is standing to the top of the hill is 29 degrees. How tall is the hill? So if we were to draw our picture, you have a hiker. Who's standing 220 feet from the base of the hill. He's looking at an angle of elevation, if I could draw a straight line, of 29 degrees. So that angle right there is 29 degrees. How tall is the hill? We want to know this information right here. So what we need to do is we need to go ahead, we've drawn and we've labeled what we know. Now we need to determine what trig ratio we're going to use. To do that, remember we need to mark our sides. Start with your angle. You have your opposite and you have your adjacent. So we're going to use tangent. The tangent of 29 degrees is equal to your opposite, which is x, over your adjacent, which is 220. To solve this problem, we would multiply by 220 on both sides. That cancels it here on this side. So in your calculator, you'll type in 220 times the tangent of 29. If you do that, you should get that the height of the hill, or your x value, is equal to 121.95 feet. Remember that your calculator should be in degree mode, and today we're going to have it set to the float of 2. Now let's look at example 2. A 30-foot ladder forms an angle of 50 degrees with the ground when placed against a brick wall. How far up the wall will the ladder reach, and how far away from the base of the wall is the ladder? Well, let's draw our picture. Here's your ladder right here, the diagonal. So let's now label the information. A 30-foot ladder, so this is 30 feet, forms an angle of 50 degrees with the ground. We want to know how tall or how far up the wall the ladder can reach, and how far away from the base of the wall the ladder is. So let's go ahead and label our sides. Starting with the angle, Again, starting with the angle, marking it as 50 degrees. We can label our hypotenuse, our opposite, and our adjacent. So let's start with finding how far up the wall the ladder will reach. That gives us the opposite. That's the opposite we're looking for. And we have the hypotenuse to work with. So we know that that is sine. So the sine of 50 degrees is equal to my opposite over my hypotenuse. Multiply by 30. When we multiply by 30 on both sides, it cancels out. Not over here. It cancels out on the right side. So in our calculator, we would type in 30 times the sine of 50, which would give us a height of the wall of 22.98 feet. But how far away would the ladder be from the wall? If we did that, we're using our hypotenuse and our adjacent. So that's cosine. The cosine of 50 degrees is equal to our adjacent, which is y, over our hypotenuse, which is 30. Again, you multiply by 30 on each side to get y by itself. So in your calculator, you would type 30 times the cosine of 50. Which in that case, the ladder is 19.28 feet from the wall. Let's look at example 3. For example 3, I went ahead and drew the picture. Example 3 says a little boy is standing on a cliff above the water and sees a boat that is 200 feet away from the base of the cliff. It is 315 feet away from him. What is the angle of depression from him to the boat? So what we're looking at is the boat, which is 200 feet away from the cliff, and 315 feet away from the boy. Remember, the angle of elevation, or the angle of depression, it goes from your line of sight when you're looking down, your line of sight to your horizontal line. So what we're looking for is this angle of depression from the line, your horizontal line, to the line of sight. What I hope that you realize, or you recognize, is that we have two parallel lines and a transversal, meaning that we have alternate interior angles that are equal because we have two parallel lines. So whatever this angle is, your angle of depression, this angle is the same. So really we're looking for this angle right here. So our right triangle is the blue that I'm about to draw. So we want to know what the angle is. So based on what we have, let's label our side lengths. The 315 feet is our hypotenuse. The 200 feet is our adjacent. So we're using cosine. But we're looking for an angle. So remember, if we're looking for an angle, we can go straight to our inverse. So the inverse of cosine of 200 divided by 315. Remember the inverse cosine when we hit the second button and then our trig function gives us the inverse because we're looking for what the angle is. That's the only time that we hit that second button. When we do that, we get that our angle equals 50.59 degrees. So that is your angle of depression. Example 4 says from an airplane at an altitude of 1,200 meters, the angle of depression to a building on the ground measures 28 degrees. Find the distance from the plane to the base of the building. We need to draw our situation. So what I've drawn is the situation. An airplane flying, and it's 1,200 meters above the ground. The angle of the depression to the building on the ground measures 28 degrees. So again, the angle of depression goes from your horizontal line to your line of sight. So this would be 28 degrees. And just like that last problem, in this problem, we have two horizontal lines and a transversal. So we have alternate interior angles. This angle and this angle. Alternate interior angles from what we studied earlier this year are congruent. So this angle is 28 degrees. Now our question asks us to find the distance from the plane to the base of the building. We need to find the horizontal distance. That's a word that should be added in there. The horizontal distance. So we want to know how far is it from the tip of the plane to the base of the building if we were on the ground. If the plane was on the ground. So we need to label each side. The 1,200 meters is our opposite. And our x value is our adjacent. So we have opposite, we have adjacent, we're going to use tangent. So we have the tangent of 28 degrees is equal to my opposite, which is 1,200, over my adjacent, which is x. If you remember the trick I showed you, if x is on the bottom, all we have to do is flip our trig ratio and that x value. So x should be equal to 1,200 divided by the tangent of 28. And so the horizontal distance from the plane to the base of the building can be found by plugging this 1,200 divided by the tangent of 28 into your calculator. If I do that, I get x is equal to 2,256.87 feet. That wraps up our lesson of angles of elevation and angles of depression. If you have any questions, I'll be here today after school for tutoring. If you need to, you can email me and I will get back with you if you're not looking at this video while you're at school. Have a good day, guys.